If you're looking at that and seeing rainbow trout instead of dead sockeye, your eyes are fine. Sockeye carcasses are red, not silver, with a pink lateral stripe. Our image generator skipped that day in ichthyology, dead fish grow forests. That is not a metaphor, that is nitrogen chemistry. Every autumn, sockeye salmon swim up to 900 miles from the Pacific Ocean into the rivers and streams of the Pacific Northwest, spawn and die, and their corpses scattered across riverbeds and dragged into the woods by bears become fertilizer so effective that the trees within 500 meters of a salmon stream are measurably, documentably larger than trees anywhere else. The sockeye salmon is, for most of its life, a perfectly unremarkable silver fish. It hatches in freshwater, spends a year or two in a lake pretending to be a goldfish, migrates to the Pacific Ocean, and then spends 2 to 4 years eating zooplankton and getting absolutely jacked. A full-grown sockeye is about 60 centimeters long and weighs around 3 kilos, which is not intimidating until you realize it is about to swim 900 miles upriver against the current without eating. Then it turns red, bright, screaming, unmistakable red like someone dipped it in a paint bucket. The color is a reproductive signal. It means I'm ready to spawn and I would like everyone to know about it. The males also grow a hump and a hooked jaw, which feels like an overcommitment to the aesthetic, but apparently works. And then it dies. Every single one, sockeye are semoparous, which means they reproduce exactly once and then their bodies shut down. No second act, no retirement. That fish is silver, by the way. A sockeye that just finished spawning would still be bright red. The color does not come off in the wash. They swim 1,000 miles, turn red, lay eggs, and decompose in the stream where they were born. It sounds tragic until you realize what happens next. What happens next is that the forest eats them. When a sockeye dies in a stream, its body releases nitrogen and phosphorus, marine-derived nitrogen, specifically tagged with the isotope nitrogen-15, which is traceable. Scientists can follow it, and they have followed it into tree rings, into moss, into insects, into songbirds nesting 500 meters from the nearest water. The salmon's body does not stay in the river, it moves. Bears are the main delivery service. A grizzly will catch a salmon, carry it into the woods, eat the brain and the roe, they are picky like that, and leave the rest. Up to 500 meters from the stream deliberately. The carcass decomposes, the nitrogen enters the soil, the trees absorb it. Some Pacific Northwest forests grow 3 times faster within salmon feeding distance of streams. 3 times, that is not a marginal effect. That is the difference between a forest and a parking lot with ambitions. What salmon provide is what ecologists call a supporting service, and that is one of 4 categories of ecosystem services. Supporting services are the foundational processes that make every other category possible: nutrient cycling, soil formation, primary production, habitat provision, if provisioning services are what. The ecosystem hands you, and regulating services are what it does in the background. Supporting services are the reason either of those things can exist in the first place. They are the infrastructure under the infrastructure. So, sockeye salmon feed in the ocean for years, absorb marine nutrients, swim back to freshwater, die, and deliver those nutrients into terrestrial ecosystems that could not access them any other way. The ocean feeds the forest, the river is the pipeline, the salmon is the truck. That is a supporting service. That is the category of work that holds the entire system together from underneath. Pacific Northwest salmon populations have declined by more than 90% in many rivers. Dams block migration routes, logging removes the canopy shade that keeps streams cool enough for eggs to survive, warming water temperatures push the thermal window tighter every year. The Columbia River alone has lost an estimated 85% of its historical salmon runs since the construction of the federal dam system in the mid-20th century, per the Northwest Power and Conservation Council's own numbers. And where salmon disappear, the forest notices. Studies in British Columbia have documented measurably lower tree growth, lower insect diversity, and lower songbird density. Along rivers with depleted runs, the nitrogen pipeline shuts off, and the ecosystem downstream of it quietly starves. The Bonneville Power Administration has spent decades debating whether to breach 4 dams on the lower Snake River to restore salmon passage. The estimated cost around $34 billion, which sounds enormous until you compare it to the annual value of the Pacific Northwest's timber fishery and recreation economy that depends in part on the nutrient system those salmon built. The math is not mysterious, the committee is just slow. Ecosystems do not have edges. The ocean is connected to the forest. The river is connected to the atmosphere. A fish that dies in a stream feeds a tree that holds a hillside that filters the water that the next generation of fish will hatch in. Remove the fish, and the whole loop starts to degrade, not dramatically, quietly, 1 ring at a time in a tree trunk nobody is reading. Thanks for sticking around. If you want more of this, where we trace the chain from one species to the system it holds together, subscribe. More episodes coming. I will see you in the next one.